Welcome to this session on AI and robotic skills, which is part of the Digital Skills Festival. We're joined today by Sarah Burnett and Dr. Andy Lowe, who are both experts in the AI field with different expertise. Myself, Patricia Barlow, who works at BCS as a product manager looking after the AI portfolio. So if we get started by speaking to Andy Lowe all around sort of AI and where it's come from to start us off.
Thanks, Pat. So artificial intelligence is about creating intelligent entities, and we often associate it with machine learning, but it's really about creating intelligent entities. And what we base that artificial intelligence on is humans, and humans are nature's best example of intelligence. And evolution has said that we are, as driven us to be conscious, subjective and objective mammals. And the human side of it we can't emphasize enough in artificial intelligence, because often when we think about machine learning, it's very objective. And actually, a lot of what we do in artificial intelligence, or when we're working with AI intelligent entities, is how they're going to interact with humans. That's a really important point. Now, we humans have been using machines since the 1900s, probably before that. So I'd like to ask you a question. What machines do you use today that involve some form of learning? And examples of that could be a search engine, it could be a smartphone, it could be a calculator. And when you look back, we've actually been using machines for many decades. And Alan Turing is often associated with artificial intelligence, and he used a machine to break the Enigma code that ultimately helped us to win the war. But AI is a little bit more than machine learning. So machine learning, its traditional definition is it's learning from data. And if we just follow down that track, we'll end up in a position where we're just using supercomputing and learning from data. And we've missed this whole rich area of humans and machines, or how humans achieve their goal. So what is human intelligence? And a really good practical definition is from Encyclopedia Britannica. That is, it's learning from experience, it's understanding things, handling abstract concepts, and manipulating our environment. And what manipulating our environment means is we're kind of achieving some kind of goal. And that means interfacing with machines, but it also means interfacing with other humans. So it's very much about humans and machines working together. Now, okay, we generally have a fear with that. We are conscious, we're subjective beings. We might be fearful of machines taking over our jobs, but really what we use machines for is to take away the heavy lifting from us. And what that leaves you is to exploit your own best talents, but also move on to higher value work. Could we have the next slide, please? So the first AI product is 1970s or 1974 by Ray Kurzweil. Kurzweil Computer Products Inc. He's written a very famous book, The Singularity is Near. It's a very optimistic book, a book all about where things could go based on the fourth industrial revolution. And that involves nanotechnology, artificial intelligence, biotechnology, and things like that. And he paints a very optimistic future, utopian future almost, of where things are going. And he was developing products in the 1970s. And so typically when we think about artificial intelligence, as I mentioned earlier, we think about machine learning and learning from data, but actually AI can be in products. So this is the first AI product. What it did is it took text and actually spoke this text out so a blind person could read a book, for example. Now, today, we almost treat it with contempt. We don't really think of OCR as being machine learning or whatever. It's just an algorithm implementing some machine learning analysis. But if you want to get started, it's a really good place to get started. It's typically the first Hello World program for machine learning. So if you want to go and do that, you can go and have a look online. There are plenty of good examples of OCR. It's now moved on, of course, and it's moved on to speech, text to dictation, and we don't see typing pools very much. So now machines have taken over from humans in typing pools. More advanced types of OCR are things working with handwritten text. So if you think about how we write, there are many variations on how we write. So actually trying to decipher text or information from text that's handwritten is much harder. And again, that's another first Hello World program that you can get involved in. Can I have the next slide, please? So now here we are in 2020, and we've made some large steps forward in machine learning. In particular, you'll see in the news deep neural networks or convolution deep neural networks, and they're becoming very, very popular again. But they started back in the 1940s, and traditionally there was part of the engineering. How do we control things in engineering? And the great things about neural networks is that we can give entities that we design, either within the digital environment or products, a nervous system. And that nervous system can learn, and we can ultimately give our artificial intelligent entities autonomy. So now we think about smart cars, smart houses, smart cities. So the neural network, which we can now use in 2020, is a machine learning technique. It's had rapid progress since 1995. So rapid, in fact, that we can learn how to play chess or Go in a matter of hours and beat world champions at it. That's how sophisticated they've become. The really good thing about this is not only we've got machine learning, which is prevalent and a fundamental enabler of artificial intelligence, we can now give entities, i.e. products and robots, autonomy to achieve a goal. They can have an ability to learn themselves. So if you go and have a look at openai.com, you can see the example on the right-hand side, which is balancing a glass of wine on a tall stick. If you remember as a child, you might have done this with a broomstick. It's very easy. Use the inertia of the broomstick to actually keep it vertical. It works really well. We can now actually train robots to do this themselves. In fact, it's usually a typical undergraduate problem to build a robot to actually balance a stick like that. OpenAI have got so good at this now that they've actually taught a robot hand how to solve a Rubik's Cube. And if you go there and have a look, you can see them doing it. Okay, the next slide, please. Okay, I'd like to hand you over to Sarah, and Sarah's going to talk about her experience of artificial intelligence.
Thank you, Andy, for that brilliant introduction to AI. The point that I would like to make in my talk is the fact that AI isn't this sort of scary, all-knowing being entity that the media love to portray it as. Artificial general intelligence still a long way away, you know, it's work in progress. In the meantime, we have a whole load of what have become known as narrow or task-based AI here today that organizations can take advantage of to get competitive edge or to improve their services and products. So here are some examples that I'd like to make to deal with customer contact better and faster. For example, there are solutions out there that, based on the history of the customer, they can match the customer in real time as they phone in to the agent, the contact center agent that has in the past done the best for that customer or has shown characteristics that means the two can work well together. So increasing the customer satisfaction, as well as all kinds of other things such as next best action recommendations, ensuring that the contact center agent is filling all the necessary forms for any kind of regulatory requirement and so on. Process large volumes of unstructured data in the form of documents and content. There are companies and organizations that have to sift through thousands and thousands of pages of documents every day, and being able to speed up, particularly where there is some degree of identifying data fields and then the values and matching them, cross-referencing with loads of other documents across the organization. So the kinds of things that you see typically in financial services, in loan servicing, for example. Even simple processes such as accounts payable require a lot of that kind of matching. Get better business insights, manage risks more efficiently, and innovate more. What we're seeing is companies that are using AI with other technologies, not alone, but with other technologies, are innovating more. Let me give you some examples that highlight these things. There are banks, for example, that are getting ahead because they do their anti-money laundering and know your customer checks online as the customer is applying. There's one that I've worked with that has reduced its customer onboarding from several weeks to a matter of 5-6 minutes. And that's because they are using technology behind the scene to integrate data, to view the data, to check it, cross-reference it. And a lot of this is driven by AI, which is also doing some of the exception handling at a low-level decision-making, not the more complicated decision-making, but it is actually doing some of the decision-making as well. And, you know, a friend of mine was wanting to open a business account here in the UK and was trying one of the big banks and wasn't getting anywhere for weeks and weeks. This was dragging out. And he told me literally that while traveling in a London taxi, they were able to open an account with a challenger bank in real time. The bank went through all the usual anti-money laundering checks as well, and all the know your customer checks. And this person had all the information on his phone and was able to open his account in real time. So guess which bank he's gone with. So this is about improving the top line and reducing the bottom line. If we go to the next, please. So it helps to visualize what is out there, and there's no easy way of doing it. So I have created this as a very simplified view of what is out there in terms of intelligent technologies. And Andy's already talked about things that I haven't put in there, like the neural networks, but they're represented by deep learning here. So if we look at the top of this picture, they're the sort of what I consider to be the foundations. They're sort of machine learning, deep learning, the fields, the big fields of AI. And of course, a lot of this depends on large volumes of data. And then the next level are these kinds of fields, subfields, the branches that sort of bring us those, sort of move us towards the narrow task-based AI, natural language processing, computer vision, and image processing, sound, voice and sound, prediction and analysis. We get technology vendors that combine these things together to create their packaged software. So we get chatbot vendors, virtual agents. They're getting better and better at this. So for example, there are virtual agents now that can keep the context of the conversation from call to call. So next time you ring, they remember what you've said and what conversations they've had with you. No longer this kind of one question at a time kind of processing. Intelligent document processing. The reason you might want to go with packaged solution is because these vendors are spending a lot of money actually developing their capabilities. I'm thinking of an intelligent document processing company that uses a technique called transfer learning, which speeds up the AI learning process. If you're starting from scratch, developing this kind of knowledge to be able to build that into your solution takes a lot of time and a lot of money. We're seeing intelligent process optimization and management as well. And what you get then, you use these technologies to create the solution that you want for your business. So it could be a virtual agent answering banking phone calls, CV screening, recommendations in online services. This is relatively simple and now quite a commonplace application. Loan servicing, and I've already covered know your customer and anti-money laundering in the banking example that I gave you. So this is the kind of progression of, starting from the fundamentals, moving towards complete solutions for you to visualize. Let's move on to the skills slide. So I get a lot of questions about AI skills. There are, to do this, for this presentation, I did some research about what kind of job adverts were out there. And I was really surprised to see that by far the majority, about 62-63% of the job adverts were actually by technology companies that were developing AI-based applications. And for these, they want really fundamental tech skills. They want Python, they want experience of deep learning and many other aspects of the foundational parts of AI, algorithm design, natural language processing, knowledge of the many frameworks. This is really important. And the point I'd like to make is that you don't really have to start from the fundamentals, because there are many freely available frameworks out there, such as TensorFlow. And the challenge with them is they're developing so fast that you need to keep up with the libraries that they're producing, making sure that what you're producing is still up to date. And somebody who understands these things would be very much in demand. Data scientists, well, if you go for the packaged applications that I've highlighted, you only need citizen data scientists, because the packages actually guide you through the labeling, the tagging of data that you need, say, for a document processing application. And this is where the packaged AI skills will come in. So look at any intelligent document processing vendor, look at any chatbot vendor. If you have skills in those, you'll be in demand. And so that's the technology side of things, but there's the human side. And I can't emphasize the need for experience design. So design thinking came to the fore a few years ago, highlighting the need for fantastic user experiences. And the same applies to AI. You need a broad set of skills, you need a diverse team, so that you can also think through the consequences of the application of your AI. And you only need to look at the media to see all the funny stories you hear when AI really goes wrong. This is because you need to think about scenarios where the application would be applied and what will be the consequences. And I cannot emphasize that enough. So if you've got experience of user experience design, if you're a process expert, if you're a product manager, you can get into this field through those skills. I'd like to hand back to Andy now to talk about the future. I think that's a very exciting part of this presentation.
Thanks, Sarah. That was a great explanation of AI in the real world, and it just shows the breadth of AI. It's often described as a universal subject and can help everybody from doctors, social scientists, artists, everywhere. That's great. So what's the future? Well, the future is beyond data, just machine learning. Machine learning is fundamental to artificial intelligence and has led to some fantastic innovations. But beyond that, we're thinking more about humans and machines and how they interact with each other. So machine learning at a very basic level is collecting the data. At an intermediate level, we're thinking about modeling the data, maybe simulating it, digital twins, and then learning from that data. And lots of people, you could say, are already doing this. Engineers, physicists, scientists will be doing this automatically. So there's lots of avenues for artificial intelligence or IT skills with artificial intelligence to fit in those industries that are already there and mature. And the great thing about that is that these people are already aware of what this technology needs to run and work. It's a good place, it's a fruitful avenue for developing your skills or working with people who are perhaps domain experts, etc. At a very advanced level, it's learning from experience. And what that means is, like the neural network, we can set either digital robots or robots into an environment, and they can learn for themselves from their sensors and their actuators, how they move around in the environment, how they mimic the human that we were talking about earlier. So AI in the future is about the creative design of intelligent entities, and those entities working with humans. So not just a single entity, it's multiple entities that could be working together, or it could be entities working with humans or multiple humans working together, or it could be the way we organize ourselves. How does the AI create an environment that's better for humans? And if we get this right, then we could unlock human potential. That means exploiting our talents, whatever they be, creative talents or whatever. But ultimately, it's not about removing your job. It's about this process leading to higher value work. And I think Sarah's examples are great examples where by getting the AI right and the process right, that leaves humans to do what they should be doing. So the person trying to start their own business, instead of starting their own business, they're actually doing a lot of documentation for a building, for a bank. That seems silly to me. So the AI was fundamentally supporting that person to higher value work. So an example of AI that's been applied is the picture there that you can see. This is the rain vortex at Singapore Airport. And Singapore Airport has got two things that are quite nice about it. It's a biophilic design. This is a very natural design. It's the buildings at one with nature, but that's also a very good environment for humans to be in. It plays to our subjective experience, and it's a very calming environment and a peaceful and a nice place to be before you go on your flight. But it's also full of artificial intelligence. So there are robots around working autonomously, delivering food, cleaning, looking after security, even parking cars and directing traffic. There are sensors all over this airport, making sure that it runs effectively and efficiently and maintains this biophilic, nice environment for people to be in. Where do we go from here? So if it's already happening now, what happens from today forwards? Well, if we look into the future, we're thinking more about the fifth industrial revolution. We're currently in the fourth, and the fourth industrial revolution is about machine learning, artificial intelligence, bioengineering, nanotechnology, and things like that, and advanced manufacturing. And that means that the pace of change can occur much quicker. But in the future, we're thinking about perhaps exploring space or the oceans. And these are extreme environments for humans. We're not kind of quite soft, squishy things. We don't like to be out in space in a vacuum, and we don't like to be deep in the oceans because it's a high pressure environment. We'll have to send machines. So extreme environments where humans can't survive are really where the future of AI is going to go. We could also think about it doing surgery. That's quite an extreme environment. We want it to be sterile. So again, designing things like robots that could do surgery for us is ideal. What is it about extreme environments? We have to send intelligent entities, and the machine learning technique, the neural network, has really unlocked that potential for the future. Okay, next slide. Okay, over to Pat.
Yeah, brilliant. Thank you. Thank you both, because there's so much to think about there. There's so much information that you've given from the kind of where it started to where it is now to where it's going and all that sits in between. A few questions really that come up regularly with people that I've spoken to, and just in general, is that kind of concern around AI in society. You've both touched on the fact that it's quite commonplace now. You know, you're expecting that personalization when you're talking to a company or on a website or even watching the TV. But what does that actually, should we be worried about it? Are the things that could potentially happen because we're reliant on the AI? So I suppose, Sarah, first of all, if you've got any thoughts on that.
I think we should definitely be thinking about the consequences, because it can go very wrong and it can affect people's lives, livelihoods, and other things as well. So it's really important. But to me, it's not just AI. There's a lot of talk of AI, but of course, technology as a whole, we now have so much technology, and I'm thinking about doorbell apps that are, you know, now being creating an environment where you can have coercive control in homes where there might be a violent partner, and it's really important to think about the consequences. And this is why I was emphasizing the need for diverse teams, the need for thinking through scenario planning of what could go wrong, and then also using any available tools that are out there for checking algorithms for bias, the data set for bias, you know, all kinds of things that are available. So I love what you've put there, which is design for all kind of thinking. It's really ethical by design from scratch. And just like design thinking became a big dimension of the whole business of product and service design, I think design, sort of ethical by design, should be the dimension that is added to the mix of designing technology.
And I can see, Andy, you're nodding along there. So I'm guessing you're in agreement, but have you got anything further that you wanted to add?
I think Sarah's explained it quite well. The ethical purpose is a key remit. The EU have been the first to publish guidelines on the ethical use of AI. And what they say is that it should have a human-centric ethical purpose. It should be trustworthy and robust. And they also propose ways of doing that. And a key element of that is design for all. also fitting into sustainability indicators. What is your service or product is going to do? How does it affect the environment? How does it affect the social ecostructure? How does it affect finances of people and things like that? So yeah, it definitely. What happens if we set off and with all the right intentions and we get it wrong? We also have to prepare for that as well. So very much an awareness, and just as we teach engineers to produce safe cars, not unsafe cars, or we teach chemists to produce medicine, not poisons. If we start to embrace AI in that sense, that's a great way forward. And the Future of Life Institute have come up with things like the Alcilomar principles, trying to help us and guide us down the right lines. So we apply AI for good. And I think Sarah's already emphasized lots of examples of where AI and machine learning is being used well.
Some of the other questions that, I mean, some of these are mine as well as other people's, is more in terms of, what happens when these robots take over. And I know you've both talked about kind of the high value jobs and it enables people to step up, but what does that actually mean? And that's the question really. I suppose, Andy, is there any thoughts on that?
I suppose it's only anecdotal. I'm an engineer by trade, and we do something called Engineering Society. And traditionally, people were fearful of cars, and so the average speed of people in London is about 9 or 10 miles an hour, and it's still the same today. It's just that instead of 200 or 300 people on a horse and cart, we now have about 6 million people in cars. So generally, machines augment what we're doing. They are what we're doing. We produce millions of cans of beans. That's automated, and we're quite happy for machines to do that. It's really our approach, and once we can see the value in it and how it supports what we're doing, I'm sure we'll be fine.
Anything further that you wanted to talk about there, Sarah?
Yeah, I think as technology develops and evolves, I think we will see this sort of reversal of roles, where at the moment, they're augmenting the human work, and over time it'll be reversed, so augmenting machines. But it doesn't mean that there won't be work for humans. They'll be there to make sure that everything's running smoothly, that quality checks are done, that fairness tests are done, all of these things, and making sure that the machines continue to run, because they do break very easily as well. But also there's a lot more to it. There's about documenting things, ensuring that the knowledge is captured and passed on, succession planning. I think all of these will require humans. And we're a long way away from that, but it's sort of important things that we need to think about and plan for.
Great. And you talked before, Sarah, you talked about the skills and those kind of technical skills that people will potentially need if they want to work in the AI, but you also talked about those other roles that kind of sat around the edges, so to speak. So they're not necessarily creating technology. It's more about managing it and ensuring things are where they need to be. What sort of skills do you think are going to be required in the future, or do you think there's going to be new jobs that appear that we don't even know about as yet?
I think as time's gone by, technology as a whole has become not just sort of highly technical oriented, but because of the user experience requirements, we're seeing arts involved in design of technology. You need to have artistic people, people who think out of the box, people who can be creative, and so we're seeing teams expand with these kinds of skills. So it is changing. The landscape has been changing for some years, and I think with AI there's an increased need for that. And also, as automation happens, it's happened throughout human history. New jobs are created. We were talking earlier when I mentioned the somebody like a social media manager. These kind of roles weren't available, weren't ever thought of before. I'm an industry analyst. When I was a child, I didn't think I'd grow up and become an industry analyst. It just didn't exist, that kind of role. So new jobs are created, and we'll see that continue in the future as well.
Yeah, and anything from your side, Andy?
Yeah, I think whenever technology has been used, certainly my background is the nuclear industry, we've all benefited from moving on to the next generation of technology. So from an AI point of view, we benefit from learning from simulations. So inside a nuclear reactor, for example, you can't send humans. So it's great that you can build a simulation and learn from that simulation. So it actually helps us from a kind of a medical point of view. Surgeons can now get a 3D image of a person, and they can actually, at the stage where they can operate remotely using a 3D model of that person. So there are technologies that are coming with artificial intelligence that will be highly beneficial. If we look at stroke patients, unfortunately I couldn't get to it in Glasgow this year, but there was a conference on how people using artificial intelligence and brain sensors to stimulate people's brains or understand people's brains that have had strokes. And those are very, very good examples of AI where people, I'm sure, would be very accepting of it. Now, with that, there's a moral side of it. What happens if it's misused? And the roles for humans will be that side, you know, the ethical use of artificial intelligence in society. And there will be lots of human roles in managing that and making sure that it's done well. Human roles also evolve in terms of ambiguity. So you might have a chatbot, and although it's a well-trained chatbot, if somebody comes on the chat who's scared of technology, or maybe confused because they've got an infection or something, or they may have dementia, it could be very confusing to a chatbot, and it would need a human to step in at that point to deal with the ambiguity, to understand that this person needs more specialist support. Another example where humans are very good is judgment. So in terms of judging something, it's quite possible you can set up a problem that's 50-50. You have two options, and how do you choose one or the other? And then that's down to the philosophers and the ethicists and the humans to make up a framework to actually understand that better. So there are many roles for humans moving forward.
Brilliant. I suppose for everybody, it's about keeping your skills up to date, because the technology is moving so quickly, and because the ways in which businesses are going to start to operate or utilize some of the technology, it's about keeping those skills up to date. It's about, I suppose, even from the, you talked about it from the machine learning, was all that learning from experience. I'm guessing that's what we're saying for humans as well, isn't it? It's to keep learning, moving forward, to ensure that we're doing this in the best possible way. Was there anything further anybody wanted to add? Any final statements?
I'd say just go for it, trial it and apply it. Don't wait. It's here and it can bring you a lot of business advantages.
Very much so. Yeah, I think learning from experience, that is a great phrase. It goes through almost everything in artificial intelligence. Take that first step and start your learning from experience. You be confident. And there's a lot of opportunity out there, and I'm sure you'll find opportunities from starting down an AI pathway.
Thank you both for your time and all of your information. It's been really useful, really interesting.
Thank you.
You're welcome. Thank you, Pat.